The next question is again quite different from the previous example that we have seen. But the question is tan power of 4 cannot be integrated. You cannot integrate this tan power of 4. So when you are not able to integrate tan power of 4, you can split that one. How can we split? We know secant square integration, right? If you try to observe over here, secant square will give us tan. So can we convert this tan square or tan power of 4 in terms of secant square? The only possibility is that you can write tan power of 4 as tan square into tan square, so that I can convert this tan square in terms of secant square. I know 1 plus tan square theta or tan square x will be nothing but secant square of x. Therefore, what will be tan square of x value? It will be secant square of x. You can send this plus 1 on the other side, becomes minus 1. So in place of this tan square, I can write that as secant square of x minus of 1. That is how I can convert tan in terms of secant and then integrate secant square, because we cannot integrate directly tan square. So hence what we'll try to do is we'll try to express. So let's try to rewrite this. So therefore I will be equals to integral of tan power of 4 times of x into dx. Therefore I can rewrite that as tan square of x into tan square of x into dx. So I'll try to replace this tan square by what value? Secant square of x minus 1. Secant square of x minus of 1, and this tan square of any one tan square can be replaced. Replace one tan square as secant square minus of 1 and retain the other value as it is. Now you can multiply the secant square with tan square. You will be getting secant square of x into tan square of x. Then minus, again you multiply this. 1 times of tan square will give us tan square of x times of what? Times of dx. Or further, if you try to integrate this one, it is secant square of x into tan square of x into dx. I'll try to multiply. This is the first integral. Minus integral of the second integral will be tan square of x into dx. So once again, how secant square can be integrated, but cannot be integrated directly. Here substitution method has to be used in the first term. On second term, we cannot integrate because tan square is there. So whenever you have tan square, the best way to solve the tan square is nothing but convert that in the form of secant square. So we'll try to convert this in the form of secant square. So once again, rewrite this one, integral of secant square of x into tan square of x into dx minus tan square. Just now we have seen over here, tan square of x can be written as secant square of x minus of 1. So hence you can write that as secant square of x minus of 1 times of dx. Now you can just apply this integral separately for each of the terms and then integrate it. And simultaneously, I'll try to use a substitution method over here. So what is the substitution method I'll be taking? Put tan x to be t. So if I take tan x to be t, differentiation of tan will be secant square of x into differentiation of x will be dx is equals to dt. Now if you just try to plug in, I will be equals to, you'll be getting integral of secant square of x into dx. This part which is there, secant square of x into dx will be acting as dt, whereas this tan will be acting as t. So in place of tan, I'll put t, but it is t square, because tan square is there, it becomes t square. Now the secant square of x into dx will become what? Will become dt. Now coming for the second term, integral of, apply the integral only for secant square. So I can write that as secant square of x into dx. Or further, you can multiply this minus of this minus. So minus of minus will become plus, and you're left out only with integral of dx. Now you can integrate it. We know the integral of power of t square, because we know that integral of x power of n into dx is what? X power of n plus 1 by n plus 1 plus the constant of integration c. And we also know that secant square of x into dx, we know the formula as tan of x plus c. And we know the integral of dx to be just x. So let us just try to, that's t power of 2 plus 1 divided by 2 plus 1 minus secant square integration is nothing but tan x. plus integration of dx will be x plus the constant of integration c. It is t. What is the value of t? T is tan. So I can write tan of 2 plus 1 will give you 3. So tan cube of x divided by 3 minus this is tan of x plus c. That will be the required solution. So very important is the very first step. If you don't get the idea of converting this tan power of 4 in terms of tan square, you cannot solve this. Because I know that I can convert tan square in terms of secant square. But even if you reach this step, here also, you'll not be knowing how to integrate it. Only after multiplying, you'll come to know that you are getting secant square into tan square. This is also not integrable. You cannot integrate this one. So in that case, what has to be done? You have to use the substitution method. So you should get an idea that you have to use the substitution method over here. Whereas the second term, even though you're getting tan square, it is not integrable. So once again, you have to adopt this procedure of replacing tan square as secant square of x minus 1. So only in one's first step, you'll not be able to know it. So you need to practice a bit to overhear this type of problem where only at this step, I had to use substitution and then direct integration. Only when you reach this step, you'll be able to complete this problem. If you are not able to reach it till here, you cannot complete the problem. Getting it? So all these initial steps, 1, 2, 3, 4, 5. These 5 steps are very important. If you get these 5 steps, that means the remaining problem is very easy. So very much necessary that you should know when to convert tan in terms of tan square and then convert tan square in terms of secant square. Getting it? So a bit of practice is required whenever you get this type of problems, because the term looks very simple, tan power of 4, but how to integrate it, that is very important.